Hello everyone. So today we will learn the importance of mathematics as an AI engineer and the reason why we learn this maths and the types also or the subjects or the courses we learn in this maths. So why maths? Why? Many students just think maths learning this maths is just a because they just consider it as a subject and they just learn it, or they just learn it because of the fear of marks or fear of getting fail. So that is the reason why they learn maths. But we as an AI engineer, we don't just learn maths just for marks, because we need to learn more about the models. We need to learn maths. What is the relation between these models and the maths? So what do? We as an AI engineer, we develop a lot of models. So these models, for example, if there is a problem, if we are given with a problem statement of predicting rain, so if this is the problem statement, this problem can be solved using many models, not just one or two. They can be solved using many models, like hundreds of models. But to solve this particular problem with accurate results, like with precise values, we need to select that model which gives precise values or accurate results. So how do we select these models? We select these models based on their internal implementation, based on their working. So these models are internally implemented based using this maths. So that is the reason why we learn this maths. So what does this math actually involve? We actually need to learn more about the probability, the statistics, the linear algebra, the statistics, linear algebra, etc. So these concepts we need to cover, and we need to have a basic idea about these concepts. So based on these concepts, since the models are implemented, we need to have a basic knowledge about these concepts. So firstly we will learn about the probability. What is probability? Probability is nothing but the chances of occurrence of an event. For example, from this problem only, that what is the probability of raining today? So that may be a question arising. So that is the chance. It is nothing but the chances of raining today. So that is the use of probability. So for example, if we set a threshold value of 0.5 and we say any value less than this 0.5, the model to predict no, and greater than or equal to, the model will predict yes. For example, our model predicted the value as zero point 0.8 is the probability. That means the probability of raining today is yes. So this is how we use probabilities to solve this problem statements. So in this probability we will learn about Bayes theorem, the conditional probability, the distributional probability, etc. So why do we need to learn these concepts? Because based on these concepts, our models are being implemented. For example, if you consider Bayes theorem, a model is being developed based entirely, a model's entire working is based on this Bayes theorem. So that is how these theorems are important. So firstly we will learn more about this probability. In this probability there are actually two types: theoretical and empirical. What are these? Theoretical. So in your inter exams or any exams, there are two types we actually work with. First one is the practical and second one is the theoretical. Theoretical is nothing but we just have bookish knowledge. In simple words, I said bookish knowledge. That is, we do it on the rough paper, we practice it, and we attempt our exams on rough paper. So that is the theoretical knowledge. And whereas the practical knowledge, we will have idea. We perform experiments. That is the experiment or practical knowledge. That is how this knowledge is being divided. So similarly, this probability is divided into two types: theoretical and empirical. In theoretical, we find the probability of event using formulas. For example, consider rolling of tossing a coin. Consider tossing a coin. Because it is simple, I choose this one. Tossing a coin. What are the possible outcomes? When we toss a coin, it may be head or it may be tail. So this is the possible outcomes. So before explaining the theoretical, how to solve this theoretical, let me give you just a formula: probability of any event equal to number of favorable outcomes by total number of outcomes, by total number of outcomes. So this is the formula of this theoretical calculation of probability of any event. So probability of any event is total number of favorable events by total events. So I will explain this formula and the working in detail. So initially just focus the difference between theoretical and empirical knowledge. In theoretical knowledge, for example, what is the favorable is nothing but what I favor, what I like. So I like probability of getting head. So in this, while tossing a coin, what is the probability of getting head is 1, because out of these two only head will occur once, so I kept here 1. So and the total outcomes, it is 1 plus 1 2. It can be either head or tail. So this is how I calculated probability of getting head theoretically. So what does it say? When you toss a coin, the probability of getting head is 1 by 2. 1 by 2 is nothing but 50%. When you toss a coin, the probability of getting head is 50%. And whereas in empirical formula, we will consider a lot of coins. For example, I took 10 coins. What does this say? If you toss a coin, the probability of getting head is 50%. So when I toss 10 coins, what is the probability of getting head is 10 by 2 is nothing but 5. It should be 5 heads. So what should occur? 5 heads should occur. So will it really occur? Will it really exactly 5 heads will occur? No, it won't be. So this theoretical formula and this theoretical value and empirical value will not be equal. This is what we think. But in general, this theoretical value and this empirical value will be accurate or approaching each other when we consider huge experiments or huge samples. For example, when I consider 10 coins, just 10 coins, these values may not be equal. But when I consider tossing a coin for a million times or more than that, for example, if you consider tossing a coin for a billions or trillions times, these values may be equal, approaching each other. If we draw a graph, if we draw a graph of these values, they may be approaching each other. These values may be approaching each other. So this is how theoretical value and empirical value will be residing each other. So this is about this probability and the types. So in this probability, we will have some important terms. We will learn about these terms now. So firstly, sample space. Sample space. Up to now I am telling samples. What is this samples? Samples is nothing but the total number of possible outcomes. So if we are tossing any coin, for example, if I'm tossing a coin, what is the possible outcomes? Heads and tails. And similarly, if you consider rolling a die, what is the possible outcomes? 1 2 3 4 5 6. So I can say this is the sample space of tossing a coin. This is the sample space of rolling a die. So similarly, picking in a deck of cards, there may be many sample space. So this is what sample space. Sample space is nothing but number of possible outcomes. So this is the main meaning of this sample space. Secondly, event. What is an event? Event is actually subset of this sample space. Event, if I this sample space is actually represented with S, and if I represent this event with E, event is subset of sample space. For example, anything occurring is an event. Anything, for example, tossing a coin is an event, and if tossing a coin, event can be getting ahead is also an event. So event can be anything. So, and this event is actually subset of this sample space. So if I consider sample space head and tail, the probability of getting head, it is an event. The probability of getting tail is an event. The probability of getting head and tail, so they don't occur at a time, but this event can be this event can contain all the elements of this sample space also. It is not like it should contain either head or tail. It can also contain both. This is the main terms we need to learn in this probability. So, and there are also experiments. When we perform experiments, there are also two types. So before telling probability, I need to tell this So experiments are actually two types. First one is deterministic and the second type is probabilistic. What is deterministic and probabilistic? For example, if you consider 2 plus 3, what is it? The answer is simply 5. So this is deterministic, that is its outcome will never change even if we repeat this value, even if we perform this addition again and again, this value will never change. Whereas in probabilistic event, if we perform tossing a coin, firstly I got head, later I may get tail, so this value may change. So this is the two types of events of experiments. We will learn about this probabilistic events, that is the probability of an event, in detail. Thank you.